Volker, this is again another conversation I had very early on. This is a man who has made so many leaps there in the Netherlands with 3D printed construction. Again, if you don't know this, and I thank you for the phrase adaptive nozzle, Stephen. If you don't know this, Netherlands is like the headquarters for everything that's happening in this space. And Volker is not only a genius in his own way, but he's also just a super nice guy. He has a bachelor's degree in philosophy, a master's in philosophy as well, a master's in international business administration, and he, has put together this company Vertico that makes this robotic arm. Now it started with just the arm, but as you can see here, is on some tracks, and it really creates just some beautiful structures. Maybe this looks all right, and that print is high quality, but I mean, take a look at this. Right? We're talking about some of the prettiest prints in this whole industry, and it doesn't just stop with one. They just kind of keep on going. Now, Volker and Vertico aren't focused on 3D printed housing necessarily, meaning like actually printing a house. They do a lot of architectural elements and other things that, of course, are attached to houses and buildings. But I am excited to hear his perspective on this entire market and what he is doing. So let me get organized here. You can go ahead and turn on your camera. Volker, I'm going to add you here as a spotlight in a moment. And he's going to give a 15-minute presentation, then get into a lot of questions with me, and then get grilled by all of you as well. So with that, ladies and gentlemen, please welcome Volker, the founder and CEO of Vertico.
All right. Alex, you can hear me?
Yeah, I can hear you. And if you'd like to share your screen, I can verify that's working as well.
Excellent. Here's my screen.
Awesome.
Here's my presentation.
I can see your whole screen, and now your PowerPoint is running. Awesome. Thanks, Volker.
Excellent. I'm going to jump straight into it, guys. Alex, thanks for the wonderful introduction. I have 15 minutes and a lot more to tell you, so I'm going to go fast, but I think you guys will appreciate that. I'm just going to show you what we do, why we do it, and how that differs from what you have been seeing over the past couple of days. So what we really do, we are in the area of 3D concrete printing, just like the rest of the presenters, but we attack it from a little bit of a different angle. So it's about a lot of automation for manufacturing as well. In 3D concrete printing, what I have seen, you've basically seen two technologies develop. One is for printing of housing, and one is for not printing of housing. When I explain to prospective customers what that's like, one is for construction and one is for design and architecture. One is focused on more the speed and the size, which has a whole different batch of challenges. And ours is more focused on the resolution, the quality, the overhang, the form freedom. So I have a background from 3D printing. I did a lot of 3D printing in my previous company in the automotive industry. And I followed the trends a lot before I started a company. And I think that a lot of the advantages of 3D printing still need to be fully adopted into concrete printing. So we're focusing on part of it. I'm going to show you quickly now what our latest setup looks like, and I'll go into the details of the machine later. But for now, just take a look at what our version of concrete printing looks like. So again, we're focused on high detailing, on overhangs, and not on structural wall elements, even though our machine is fully capable of doing that. So what we do is we utilize ABB robots, or any robots for that matter, but we prefer ABB. We've connected the My Multi-Mix pump, which is a pump from Austria, which has been able to handle every single commercially available material on the market thus far, making it a very versatile machine. We have partnered with them to continue to develop this machine and the technology around the machine. We have our own slicing software to make these parametric times designs and translate them to robotic code. And obviously, over the years, we've built a lot of experience in succeeding and failing when it comes to trying things in concrete printing. So this is what we do. I want to show you some projects we've done in the past. A very early project is this Voronoi wall. It's an example of parametric architecture. So all these elements were designed, and when construction came, the deadline came, we noticed that one wall needed to be a meter longer and one a meter shorter. So we were able to adjust just 2 parameters in our software, and the full code was generated just from the same script that was written, making it very easy to produce these items and very flexible in construction, which is really helpful when decreasing the failure rates or the failure costs. Here is a good example of topology optimization, and Theo just before talked about this. They're doing a big project in this. This is an early collaboration of ours with the TU Ghent, and here you can see one of their simulations of how the topology optimization functions. So this bridge was designed by the computer from A to B with a minimization of material. And what we realized is that what you generate, obviously, with topology optimization is very organic shapes, very round shapes, which are expensive to make by hand, but not by machine. And this is the end result of those early experimentations. And I'm very keen to marry the potential, the form freedom of 3D printing in concrete and this topology optimization. So more than just making weird, nice, pretty stuff, you got to really focus on why you're doing these things, right? Which one of them can be aesthetics, right? Looks pretty. That's a perfectly reasonable thing to do. But another one is structural engineering, right? So what are the structural properties? This is another great example of this philosophy of marrying different types of strategies. So this one is a compression only structure. It's fully concrete printed. There's no rebar inside. So we avoid the question of rebar. And when you look inside, it's just like a church roof. So it's a compression only structure, right? But this is an extremely complex print because it has a varying layer height. It has a curve, it has a double curvature, it's very long, 3 meters, and it has about an 80% height difference from beginning to end. But it makes for a very impressive object. What we add to the market is we are one of 4 companies in the world that have developed a machine that adds accelerant to the print head. So what you can see here on the right is our accelerator nozzle. We pump our concrete mixture to the nozzle, then we add the accelerant, and this hardens the concrete within a matter of seconds, allowing us to make, impressive aesthetic patterns and impressive overhangs. A lot of demand now for this type of production because it's very good for creating complex shapes. These are shapes for experiments by the TU Delft and the European Space Agency for habitation on Mars. So I want to show you, this is what we can do with the technology, but I also want to emphasize what the difference is in technology. So what we have here is our accelerator print head, but the more basic print head is what we call the monomaterial print head, also known as the 1K print head. And this is your standard print head that you've seen in the past 2 days. We've been working with Sika to develop material. They have their 1K material available. We've also printed with the Heidelberg material. We also have our own material. So we're very flexible in that. We are not partnered with one specific material developer alone, which means that if you buy our machine, you can use whatever material you like locally, whatever's available, or you can get our recipe and produce for yourself locally. So we're not in the business of shipping material around the world. So our robotic machine is capable of printing with this 1K mono material because the robot's the same, the software is the same, and the pump is the same. The only thing that's different with our more complex machine is then the nozzle and the dosing pump required to run the accelerant into the nozzle. But this is the basic printing, like most concrete printing setups. One of the reasons why, and I wanted to say this on the housing conference because they're focused on, gantries or robots. The main limitation of a robot is its size compared to a gantry machine. It's that simple. It's more flexible in terms of degrees of freedom, and it's more flexible in terms of having local tech support because these robots have been serviced in the automotive industry worldwide. So in terms of a sure shot uptime, it's very easy to use a robot. One of the reasons we use a robot as well is because they're very readily available and we do prefab production, right? So getting a gantry in-house is more expensive than getting a robot. And producing at this size means that you can make faster iterations. So you see a lot of concrete printing companies getting a gantry, struggling early on to make simple prints and practicing because it's quite a large machine, right? It's capable of great things, but it's a large machine. Getting a robot to get up and started will definitely increase your learning time, right? It'll go a lot quicker. So it's a good idea to have both. We have our accelerator print head, which is our flagship product, so to say. And there are, as I said, 4 companies in the world that have produced this technology. There are 3 that still sell it. So it's a very niche market. And there's an incredible boom going on right now in the housing industry. But I think that concrete printing is able to offer much, much more than constructive printing alone. So on the left, you see the columns that we produce. And these columns can be structurally sound in the sense that what we do is produce the formwork, then we insert rebar and we pour with traditional concrete. So what we do well is avoid issues like the regulatory issues you have everywhere by still using traditional methods of pouring and rebar to ensure that we meet code and to ensure that we have structurally sound items. At the same time, we can produce monomaterial using the same 3D printed concrete, and we can produce an incredibly striking aesthetic effect. So the column on the left, as you see, was produced in about 70 minutes, so about an hour. And that for us right now is a relatively slow speed. We can go much faster, but because we're in the experimentation phase with these type of difficult aesthetics, we don't need to. So within an hour, we have this product. And one of the things that stands out in our technology is the consistency with which we print. So you can see very few blemishes across this, or, indeed the column, any blemishes. And that's something that's very important when you want to reach such a high quality. Right, when the quality of your products and the aesthetic appeal needs to be at a certain level, it's very important to have that. In my opinion, now we have a lot of discussion about, do we want to print with lines or do you want to, smooth them out? I think there's a lot of potential still to go with playing with the technology, right? Like we do in these 2 pictures, showing that we can go in and out, we can go up or down, we can go curvature, and to really get this appeal going, right? There's a lot still to be had. What we're moving towards now is we're moving towards a lighter concrete. So we've been working a lot with Sika to develop new material that's lighter and use their white cement, because that also allows us to move into adding colorants. So there are some companies out there that are doing similar things. It's not a priority for us because we think the aesthetic appeal is certainly still underdeveloped, but we'll be moving towards adding a whiter cement and colorants. And for me, one of the visions of concrete printing and what it can bring is just imagine even a simple structure like a parking garage, right, where you have a lot of columns, and instead of them being straight and using a lot of formwork and using a lot and producing a lot of waste in that sense, you can have this beautiful set with 50 different columns of 50 different shapes, sizes, and patterns, and topology optimized from front to back of the building if you're being smart about it. And you can just, for a minimal extra cost or relatively low extra cost, you can create an incredibly appealing project, even in something as simple as a parking garage, let alone talking about lobbies or houses or villas or whatever. So we focus more on the peripherals of the construction industry with 3D concrete printing, because we think there's an incredible appeal. But our machine can do both. If you buy the accelerator nozzle, it also works for the one component. So you can still produce your wall elements in prefab structure because it's the same pump, it's just a different material. And if you have the accelerator nozzle, which is more complex, you can also produce the furniture and you can produce the aesthetically pleasing elements. And what you often hear is people that say that use the construction printing technology to try and print the aesthetically appealing elements. And time again, you just see the mismatch. The print bead is too big. The cornering is too slow or too inaccurate or too large or too much radius. And it's just not the match, right? So we're going to see in the future that the client's not going to be satisfied with just a novelty. They want to be satisfied also with the quality. And our business model is going to be producing high quality elements as well. One of the things we're going to launch next is planters and columns as a product line. So we're working with our clients that have bought the 2-component machine to introduce them to our product lines as well. And in that sense, sell our product line along with the machines themselves. I think it's about it for the time that I have. I'm sure there's a lot of questions. One final slide here to show you just the range of robots we work with, from the smallest that get put into laboratories, the lab scale robots, to the largest on track that are capable of producing 10 meters by 2.5 meters by 3 meters.
Volker,
So
awesome stuff. I'm coming on here
yeah,
in a second. You just give me a minute to get myself spotlighted. But ladies and gentlemen, I hope that you can understand why this guy has a really interesting and unique perspective on the market. And again, getting a lot of folks today, yesterday, Volker, all saying that, houses are good, right? Make houses, make a bunch of them. We need that, but there's more to this, and so we're gonna get into an interview now, Volker, where I'll ask some prepared questions like I have in the past, but then we're gonna get all those questions from the audience here. We've still got another half hour.
yeah,
With her, so if you felt like that was too short, don't worry. We're gonna have some more time with him. The first thing is they're so pretty, right? Okay, they're just like they're kind
yeah.
of yeah, honestly unbelievable sometimes. I'll see you, I follow you on Facebook, I'll see some posts, and there are so many renderings in this industry that I'm like, is that a rendering? I'm looking at different vendors, and I always have that double take with your stuff because it looks so good. But
We've
this
never
is not,
rendered anything. Just just to put
yeah,
that out there. I've
there you
never
go.
done a rendering.
Not enough time to render things. We're too
Now we
busy.
have time for that. You keep going.
Yes. But what is the temperature, humidity? What are those print conditions that are, obviously it's got to be in the mix too, but what are the print conditions that are making this possible?
All right, so that's a good question, and it's a complex question. So it's something we've discovered trial by error. So as a startup, we were able to move into a space in Eindhoven, which is an old factory where we were allowed to just have space for a relatively affordable price. The problem being there's no heating in the space. So in the winter, we have, inside the production facility, we have, 1 to 2 degrees Celsius. And in the summer, we can get up to 30 degrees Celsius. So there's a really large range. Now, what we found out is that we can produce in all temperature ranges. However, you want your temperature range of your concrete to be within a certain set. When we produce with our accelerants, our concrete can get up to about 35 degrees when deposited. That's a acceptable level, right? That means that it's going to harden fast enough to produce the 40, 50, 60 degree overhangs that we want. At the same time, it's not too hot that it's going to crack or damage or dry too fast. In terms of humidity, we've worked in a range as well. Having a wetter space in terms of humidity is nice to have, obviously, because it's very good for the drying, curing of the concrete. We do use curing compounds. We cover with plastics, and these things are important when guaranteeing the quality of a product like that. But there is a range. So let's say 15 to 25 degrees Celsius is a nice range to work in. In terms of humidity, high is nice also. But there are, especially in early stage 3D concrete printing, if you open the door, that will change your print because a breeze will come in, some air will come out, it will change the temperature. And I've seen prints fail or succeed just based on if somebody has opened the door or not on the other side of the hall. And it's not because it's that sensitive, but there could be a large delta. So be careful of weird things like this. So we monitor a lot. We have to monitor a lot.
And we were talking with Dr. John Belkowitz at Intelligent Concrete, an applied materials scientist, and he does a lot of testing. We had a debate about tenting and how important could tenting be outside. Obviously, you're printing indoors, but I think just wanted to stick to everybody. Opening a door can change your print, and so do we always need it to be as perfect looking as some of Volker prints? Honestly, no, but we do need to understand that this is a sensitive material. It's harder to work with. Now, I want to see if you can dispel something that I've heard. Maybe it's I'm not right on what was said to me, but I was told that smaller prints are actually are harder because the set time, like you can't just print right over something that you just printed because it's not setting fast enough. But that seems to be wholly untrue, at least in the success that you have had. People have told me that, well, a longer lap around that print is going to give you some time to set. Maybe that's truer for outside conditions or other things, but smaller prints, easier, harder, unique challenges.
Yeah, I can give you a quick rundown of the important things there. So we have this, as I said, this construction printing and this architectural printing, and everything in concrete printing. What I've noticed so far is sort of there's a range, there's a spectrum. What you can do with the construction printing when you're talking about with this one component, where there's no accelerant involved, it's just the dry mix alone. If you have one of the faster ones, you can print a column of about a 1 meter circumference that will continue to print without collapsing. But that's the smallest thing you can print, right? So anything bigger is fine, except the bigger you go, the more you have to be aware of your lap time, and the more you have to be aware of your drying time. So what I've seen in larger prints as well, if you make a wall that goes to your entire house, you can have shrinking occur in the beginning. So you have to be careful that you've optimized your mix for that. The smaller prints, the opposite is true, of course. You can go to a maximum of, let's say, for very, very large prints, you don't really want to go over 3 or 4 meters because you're accelerating too fast, right? So there's a very small overlap for which you can use both materials. But generally, if you're doing a very large object, go for the one component, which is slower in setting. If you're doing smaller than 1 meter or 2 meter, then go for an accelerated mix, because that'll give you the better structural stability.
Yeah, and I think this kind of goes back to that thought of, as the years pass, how is software going to play a bigger and bigger role? Because what you just described to me sounds like a nightmare, right? Meaning it's like too long, too short, inside, outside temperature. However, software can help control some of these things and say, okay, well, your print is this long, and it's the lap time is this, and so because of that, you need to change these two elements, and your hose length needs to be this length. So here's a list of what you need to make this successful. I know it sounds scary to everybody, but again, listen. Humanity has been here before. We've had problems that were just too complex to juggle all at the same time, and so we don't. We find solutions to make this happen. And Volker, like he said, making his own software. I'm sure there are pieces and parts of this that play into that. We've got a. Oh, sorry. Go ahead, Volker.
Let me just add one thing to that, if you don't mind, because I agree with you there. And about 3-4 years ago, when I started with this, I was, I watched Theo as well, and I was very much inspired by their work. 3-4 years ago, we were really
wait. You just said Theo. Am I supposed to call? Is this name pronounced Theo, and I've been saying Theo?
Yeah, it's Theo, but Theo's fine. I'm sure it's fine. I'm sure it's fine.
I've called that man to his face, Theo, like 50 times, and no one.
I'm sure
in our organization. Okay, I'll get over it.
I'm sure it's fine. We're all Dutchies here. It's a small group, but I followed their work from early on, and 3-4 years ago, it was really in its infancy. It isn't anymore. I'm in a phase now where today, I'm not in Holland. I'm actually on holiday, and my team had printed a canoe today, which 4 years ago was the hardest thing I ever did, was a 3D printed concrete canoe, because I had no idea what I was doing. Now they can do it by themselves, and in a way that's 10 times better than we did before. And the industry is now in a phase where we're actually looking to invest, because we know what we want to do. We know what we want to automate. We know what we want to measure. We're really in a phase where we can do the basics well, and we are improving, right? So it can be done. We're out of the infancy phase for sure.
Nice. And we do have a lot of folks internationally here, but also focused on the United States, where we pronounce everything wrong. We don't understand Celsius and a couple of other things. But printers, customers in the United States, do you have presence here?
Yeah. The United States right now is booming when it comes to 3D concrete printing. I think maybe 30% of requests I get are from the United States. It's really incredible. We have installed one machine on the East Coast. We're installing another machine in Florida this year. We have great interest. Well, won't mention too many because we're in a lot of early phases, but it's really booming. A lot of universities are moving into the space, but also a lot of commercial enterprises are moving into the space, mainly housing from what I've seen. But at the same time, you see that other people have the same insights that I do, that there's more to it than just housing. And they're moving into, the furniture, the planters, the columns, the more unique objects. So that's definitely popular. So we will be installing another machine this year. We will most likely be installing 2 or 3 next year.
Okay. And one of the things that we've even talked about, because I'm talking to all these speakers almost not only from organizing this conference and researching, but honestly from a prospective customer type of thing. And one of the things that Volker said, and in his our sales cycle together, just talking, and I don't own a printer, but the thought of, some of these machines, $700,000, $1 million, they're really big. And one of the things that Volker said in his earlier presentation is that barrier to entry, getting started, learning the lessons, can be very important. And so we got a question from Troy, which, is sometimes hard to answer, but if you could give us any sort of range on a cost of a printer.
Yeah, I can give you a full rundown. I do this every day. So it depends on what you want to do. That's the most important question. So there are basically 3 types of machines we sell. There are machines for laboratories. So we do a lot of stuff for concrete laboratories or universities with laboratories that want to do material development. In which case the machine is small, the pump is small, a lot of it's hand done. We have a small machine, which is mobile, plug and play, no installation required from us. It's about 50,000 euros. Then you have the 2 different styles of machine. You have the construction printing machine, which is our simpler version, which is the pump, robot, software, material recipe, etc. You're looking at about 100,000 euros. If you want to go full on with the accelerator nozzle, the 3D printer on track, all the bells and whistles, you can go up to about 230,000 euros. So that's about your price range. And for the construction 3D printers who are buying cobots or Black Buffalo or large gantry styles, again, I can recommend buying a small robot too, to hook up your pump or to buy a machine like ours, because it'll help you iterate much faster, and this will save you costs in the end. So I can really recommend you do that. But these are the 3 sections we have.
Yeah, I mean, $100,000 in the grand scheme of this industry and heavy machinery and construction costs, it's not that much. And so, thank you for giving us those thoughts. Wanted to see other client examples, right? So we saw some planters, we saw, some columns, but like if we think of what you can add to a single family house, I know that's kind of narrow and the market needs to be wider than that, but this conference focusing on housing a lot of single family homes. What are some of the things that you can, that a client buys a robot, they can print and say, hey, these 4 things, these 3 things, add them to your house. It's going to make it much more beautiful. It's going to be cheaper, et cetera, et cetera.
So for, the main thing for in the housing is the columns, right? Columns and wall sections. If you have a unique bit of wall that you want to leave exposed and that you want to have done really nicely, that's what we do. So columns and wall sections really work really well. Obviously they have to be prefab and transported onto site. Another thing that's booming now is the planters, which are, semi for housing. They're more for outside garden furniture type stuff. But again, as I've said, the housing printing market is not necessarily our focus. We are, in talks now with someone that's doing a pool house, and it's quite a unique pool house. So these type of things, with unique wall elements, when you have really an eye-catching piece, that's what you can do with our technology, right? And it's driven a lot right now by hype. And if you want to really seal the deal on this hype, this quality that we can deliver matters too. So those are the things. It's columns, it's wall elements, it's unique structures that you're doing on site that can't be done with your straight walls.
Yeah, and with all due respect to Volker, because the guys, I mean, obviously see his work, it's amazing. He's busy with software and robots and clients. Volker has not yet thought of everything that robot can do. I know.
Not even close.
Right? It's just the nature of technology. The more customers that he gets, or any of these vendors get, we're gonna come up with things. So even though some of his comments and realities, because he's trying to be honest with you, he's saying, well, there's these aesthetic pieces stuff. There are uses for that printer that not yet discovered in the case of every single 3D printer showcase. So I appreciate your perspective on that. Sure. This is kind of a basic question, but most common mistakes during printing, particularly with your technology, those curves that you're working constantly with with your customers on that are kind of more detailed? Obviously, we know like the mix can be a little bit wrong, but is there something else out there that you're not going to find in the YouTube channel? Something that is like, well, yeah, these are some of the lessons I've learned.
Main lesson: shrinkage. Shrinkage. Beware of shrinkage. It can be controlled. It can be controlled successfully, but you have to beware of shrinkage, right? So this is when you're printing, you don't add curing compound, which sometimes we don't have to, but sometimes we do, depending on the geometry. And this is based on experience. Shrinkage is an issue. You can add plastic over the top of an element to cure it. This helps a lot. Shrinkage is a big, is an issue for any type of concrete for sure. That's the lessons learned. When you're talking about use of robotics, there are many lessons that I could give you. One of them is you have to simulate your print path. So you can design your object and run it through our slicer, but simulate your print path. You got to be careful that you don't run the machine into the ground because you've set up your nozzle differently, or change the height of your print bed. So level your machine and simulate your print. These things will save you a lot of time. Another thing is, the third one is, the main thing in all these spins is cleaning. Clean well, clean deep. Have a standard for it, and because when you start up your machine, if something isn't cleaned halfway through the print, you can get issues. So these are probably some main issues you got to be aware of.
I can't believe that actually hasn't come up in the 2 days that we've been doing this. My brother owns a construction company, and I got this sample because he went to a Cobot training.
Yeah.
And, we were talking about, well, what if we printed things inside and then we transport it, right? Obviously, a lot of people have been talking about that in many business models. But he was like, Alex, where's all this water going to go? Because I'm like, what are you talking about? He's like, there's just like we got to clean these hoses immediately. It's got to. So that's just something that a lot of people don't realize. Like, this water's you got to clean a lot of stuff, and it is time sensitive. So that thought of what you're saying, almost like a checklist, a process to make sure that your cleaning is at the effective level. Let's not ruin $100,000 worth of equipment.
That's what it is. Yeah.
Yep. This
waste of time.
Coming just off that shrinkage question, Hallie says just percentage of shrinkage. I don't know if you've got any measurements or thoughts on that, of like what kind of variation we're talking about here.
So first, you have to ask Theo, or this is their area of expertise. This is what they do. There's literature on this, and secondly, it also depends on what material you use. So if you have a material with a lot of shrinkage reduction agents in it, you might get better results. But thirdly, it also depends on the geometry that you print. So especially when you print more complex objects, you want to be careful that you don't print a very small section with a very deep inlet, because that's where the shrinkage can occur most heavily. So there's different factors that play a role in what percentage of shrinking you get. What's your humidity? What's your temperature? What's your geometry? What material you're using? So it's not that easy to answer that question, unfortunately.
Yeah. No, that's fair. And we've even seen this in the comments in the chat before. It's like, there's sometimes just not a lot of direct answers here because there are so many variables. And that's why you need to work with experts like Volker, like John, like all these people, and even going through training. That was another question. Volker, do you have a training program of some kind for your clients or others?
Yeah, by now it's mandatory. We've had clients that said, "Oh, we'll figure it out," and that's not good. That's not what you want. When we sell a machine, we have hardware training included. For the larger machine, you have 5 days of training on our location, and when we install the machine with you, we do another 5 days of training. We have an online robot training course. So if you have robot experience already, great. If you don't, I recommend taking a course with us or with a local robot trainer beforehand, so you get those basics out the way. So you can focus on actual lessons learned of concrete printing. So robot printing, robotics is something you want to do prior, which you can do online. It's not too bad. Then you get slicer training on how to create your geometries, and then you get hardware training, a bit of material, but a lot of hardware and actual, process training. So it's all included in the purchase.
Awesome. Kevin is backstage right now. And one of the things that we've struggled with, Volker, is like almost like an insecurity as we enter this market. Because one person that we're working with. Paul, he's built 1,000 units, but he's like, I don't know what a 3D printer is. Then we go look at Kevin's like, I know everything about 3D printing, and I have no idea how to build like a garden shed. And then I just give nice presentations. So anyways, all equally valuable people. But what I want to point out here to Kevin, who I hope you are listening virtually backstage, is that there is a need for understanding the slicer, the software, the technology. We've talked so much about mechanical, electrical, plumbing, and permit codes. Obviously very important, but you got to have somebody who understands how to use this robot, how to use the gantry system and the basics of this. And if not, they're going to have to go through a learning curve. And as impressive as I'm sure Volker's training or everyone's training is, it's still going to be that. It's going to be a learning curve. They're going to have to master a couple of things. And so if you are in 3D printing on a desktop, at least you have a foundational understanding of what it is we're even talking about, or Volker mentioning robotics training. Robotic arms have been around for 30 years, whatever the number is. It's not new at all, and that can translate. So it'll be interesting to see how that all works.
Yeah,
all right, let's keep going with these questions. Well, I want to mention this thought of topology optimization. There's a question about just, do you think it looks more aesthetically pleasing? Well, I'll answer that to say, yes, I do think this. But again, this is something that I learned in my journey of something that is not, well, certainly as just a layperson, you wouldn't understand. But it's not just that it looks interesting. It's that it's removing material. All those gaps in that pretty webbing looking whatever we see in these presentations isn't just pretty. It literally is removing material, means that we're destroying the environment less. Not only that, but if you have things that are heavy, like it's just fill it with concrete, more doesn't mean more structurally stable, right? Even think of the concept of an overhang that we saw. Do you want a heavy overhang or do you want the lightest overhang? You can't. You don't have to be an architect to understand, the basics of that. So topology optimized structures are going to save you material. They're going to look better, and they can actually literally last and stand longer. So that was a revelation for me a year ago.
Yeah, I agree. I'm completely convinced by topology optimization for the reasons I quickly touched on in the presentation. Is that it's 3D printing, and I do 3D printing because I really, really like 3D printing. I don't know. I caught the bug of 3D printing. I like making stuff, and I caught that bug. But in the end, nobody should care that a thing is 3D printed. Everybody should care about the object in the end. What is its intrinsic value? And in that sense, when you use a strategy like topology optimization, that's when you're adding the most intrinsic value to your product. The fact that 3D printing is the key to unlocking this intrinsic value is interesting to me. And that's why I think this topology optimization is going to be successful. Just like function integration is successful in traditional 3D printing. But this is a little bit deeper level. But there's got to be more to it than the printing alone. And that's one of the big questions for housing printing. What exactly is the value added of the technique to making a house 3D printed? Like, it's not about the fact that it's 3D printed. It's what is the value that you're adding by printing it? And that's an important question to me.
A question about special shipping needs. Obviously, shipping that over. And not only the robot over, but let's talk about even like shipping these pieces of a bridge or whatever. Like, let's actually focus there. How does that packing look? Is it any more complicated than shipping anything else? I mean, on the outside, how does that work?
Yeah, it's a good question. It's nice and practical. Good examples are the planters we're doing now. My strategy is that planters is a local industry. So from the Netherlands, when we print planters, they go to France, Germany, Austria, maybe Belgium, everything that's close to us, because it doesn't make sense to ship planters to China or Australia, right? That's just too far away. It's better to put a machine there. So machines is an international business because there are a lot of 3D concrete printers in the Netherlands, as you well know. But production is a local business. So when it comes to local shipping, relatively standard operating procedures apply. The biggest challenge you're going to get in transporting, especially products, is maneuvering your product from your print bed or your space onto your transport. So if you're lucky enough to have a space with a crane, you're doing well, that you can drive a truck into. This makes life a lot easier. But most of the spaces I've seen don't have that luxury. So it's sometimes it's really an operational struggle to get something onto a truck. Once onto a truck, it's relatively traditional, but just getting stuff off your print bed onto the truck can be a logistical nightmare in your own space. So that's something to be aware of when designing.
Yeah, that makes a lot of sense. Another question that I had, this is actually something that maybe I heard from Mudbots here in the United States, but thought of concrete planters, not a huge market, but just an interesting case example, let's say. Even folks who are watching right now, if you've got multiple monitors, go Google how much a big concrete planter is, okay? A big concrete planter is literally thousands of dollars, right? And even a small one is going to be at least hundreds of dollars. If you have your print operation all set, right now, you got to, of course, think about the asset cost of the robot and the talent to do it and stuff like that. But I heard that some of these concrete planters, like the material cost is like, you can sell a $1,000 planter that also looks way better than any planter you could buy, by the way. The material cost is $70, $80. Is that true? Or, what are your thoughts on
so this
that?
is 100% true. And, as you probably will know from me by now, I'm just going to give you, the state of the art of what I know about this industry, because we're really getting into it now. We have a product line set up. We're going to launch soon with our planter set. So what actually happens is every time we print, we warm up the machine. We do a small planter just, to get all the settings right. And these planters are just experimentations, but they ended up being so nice. We started to develop a product line off them. And by chance, we got 4, 5, or 6 RFQs from companies wanting to do planters also. So we're really getting into it. So now we're doing the business case. Okay, so what does a business case look like? And what it's come down to for me, I've realized, is that as long as there isn't too many middlemen, there's a big profit margin to be made. So I can do a normal planter from anywhere from $20 to $50 of material inside. And it's relatively high for concrete, but it's relatively low for a planter. I can sell the planter for $125 to $250. So you're making a nice margin there, as long as you're producing volume, right, with your machine. But that's what they're made for. These are machines to be filled. Right now, they're all standing still, which is fine for this stage in the industry. But at some point, you want to start filling 4 or 5 days a week, maybe even 2 shifts. And that's when you're really going to start producing this cash cow. So we're developing, this business case now. And if you sell straight to end client, you're making easily 9, 10, 12 times what you put in. But the thing is, you want to sell to a distributor, and the distributor will sell the end client because there's a risk involved there. So we're focusing now on larger projects for hotels, for office buildings, for whatnot, 30, 40, 50 pots. Bigger volume, bigger margin, lower risk, longer lead time. So it's manageable for us in project sense before we really start doing the, IKEA style, let's pump them out.
Yeah, lots of different business models to discover in this industry. And you're absolutely right about asset utilization rate, right? You got to keep that printer going. I even yell at Kevin when we're in business meetings. I'm like, it's just his desktop printer is always moving. It's like, if it's sitting still, that thing needs to be printing me money. Yeah. He obviously has, industrial clients and things like that. Anyways, we got to think that way in this space as well.
Yeah.
Well, Volker, the last question that I have is, how do you say your last name so I don't mess it up right now?
You got no chance, but thanks for asking. So it's Ruitinga in Dutch.
Oh, come on, man. I was hoping you might fake something easier for me to say. I will continue to say Volker.
Ruitinga will do.
Yes, I cannot thank you enough, Volker, for your time with us. Again, on my journey, learning about the different things. The guy doesn't know me from someone down the street. He took the meeting. He gave me some education on this, and it's been very helpful. We really appreciate your time at the 2022 3D Printed Housing Conference. Ladies and gentlemen, huge round of digital applause and thanks for Volker. Volker, please drop in your LinkedIn, website information, ways that people can get a hold of you. Thank you again.
No problem.